Hi everyone. We're going to jump into radical functions now. Radical functions kind of follow what we've just done because they are the inverses of our quadratics and cubics and so on. So the first thing I want to touch on here just to get us started is domain, but we're going to basically go through all of the things that we've talked about. We're going to go through transformations and difference quotients and composition and inverses, all involving radical functions. And the idea and concept behind it stays the same. Mostly what gets messier is the algebra. There are spots where the concept gets a little trickier as well, but a lot of times it's just messier algebra as we work with more and more different functions. Okay, so domain. So far the parent functions that we've worked with, linear, absolute value, quadratic, cubic, the domain of all of those is all real numbers. Some of them have a restricted range. Some of them only give you positive numbers. But the square root function is an interesting one, and this would be the same for fourth roots and sixth roots, but the square root function is our parent function. If we remember what it looks like, there's a rough sketch. It has a domain of x greater than or equal to 0, and it also, not for this question needed, but just to mention it, has a range of y greater than or equal to 0. So both the domain and the range have a little bit of a restriction on them, and that's for plain old y equals square root of x. So this adds our first parent function where we have something to check in the domain. And the thing that we want to check in the domain is that we're never taking even roots, so square roots or fourth roots or sixth roots, of negative numbers. It is completely acceptable to take the square root of 0. So don't worry about that at all, but no negative numbers. While we're at it, I'm also going to mix in a fractions problem. We'll hit this a lot with rational functions, but we can also see here that I've given you some fractions. So our two questions that we need to ask ourselves right now for domain are we taking the square root of a negative? If so, we need to restrict the domain. And are we dividing by 0? Neither of those things are allowed. So if we have either of those possibilities, we're going to have to be careful. Okay, so in this first example, there's no fraction, so I'm only worrying about the square root of a negative. And basically, sometimes you can just look at these and say what the answer is, but otherwise you just end up solving an inequality. So what we need to be true is that the entire thing under the square root, the 2x plus 1, has to be greater than or equal to 0, cannot be negative. And this is a linear inequality, so we can solve it just like we would a linear equation. We just have to remember that if we multiply or divide by a negative number, it will flip the direction of the inequality. We only have to multiply by 2, however. So this is our domain right here. And if you want to be a little more formal, you can put squiggly brackets. I'm not real worried about it, but that is formal set notation to put some squiggly brackets. So x greater than or equal to negative 1/2. And as usual, you can also use some interval notation, and that would look like that. So either of those is fine. So if you see a square root, make sure that you take whatever is underneath it, set it greater than or equal to 0. That will tell you if you need to restrict to make sure that you don't have square roots of negatives. The second one is a little bit messier because we now have both problems. So we could start as we did before. Let me switch colors and say, okay, well, 5 minus x is under a square root, so it has to be greater than or equal to 0. And I can actually avoid the dividing by a negative number if I just add x to both sides. And it tells me then that 5 is greater than or equal to x, which means the same thing as x is less than or equal to 5. Okay, but that's not the only thing I'm worried about. I also want to make sure that I don't divide by 0, right? We had two problems, square root of negative, which I just made sure that I eliminated, and division by 0. So because we have that square root in the denominator, we actually also have to say that x can't equal 5. And again, if you're having a hard time spotting these, if they're ever messier, you could take that square root of 5 minus x and set it equal to 0. But I bet for that one, it's not too hard to see that if x is 5, we get the square root of 0 in the denominator, which is not acceptable. No zeros in the denominator. So this part becomes kind of just a logic puzzle. And this is the thing that's slightly tricky with domain, is there isn't just a do these steps and that's your domain. You kind of have to analyze whatever function you're looking at and see if any of these problems exist. So if I need to exclude 5 from the domain, I'm just going to come down here and I'm going to say, well, let's just erase the equal to. Oh, and I erased a lot more than the equal to. Hold on. X is less than, strictly less than 5. So my final answer is going to be just X is less than 5. So you're allowed to just make judgment calls like that. Okay, and last but not least, just to show you some of the kind of messy things that can happen, we have 3x minus 5 under a square root, so we want to make sure that's greater than or equal to 0, which means 3x has to be greater than or equal to 5, and x has to be greater than or equal to 5/3. Okay, so that's fine and good, but I do once again have to think carefully. I've made sure that I don't have any negatives under square roots, but once again, I do have a fraction, so I do have to think about division by 0. So if I look at that denominator, I would also have to say x cannot equal -4. And actually this time, I think I'm covered. So again, this is where you just kind of have to look through and analyze the information you have. If we're saying our x has to be greater than or equal to 5/3, which is 1 2/3, we've already excluded -4 just with that initial statement. So while it was important for me to go look at that and check, I actually don't need to write both things down. I've already got it covered by saying the x has to be bigger than 1 2/3. I will not get 0 in the denominator if I'm following that rule. So always watch for both. These will get a little messier, like I said, when we get to rational functions as well. But for now, I wanted to show you some of the variations of what can come up.